Hello student, today we will discuss the Lensmaker formula. Lensmaker formula. Yesterday we discussed the refraction from curved surface, rarer to denser medium, rarer to denser medium, and the surface was like this, P, O, and the ray like this. This is normal. The line which passes from the C is normal, and the final image is formed here. And two medium, one medium was N1 and one medium was denser medium, that is N2. So in that case the final result was N2 by V, N2 by V minus N1 by U. It is equal to N2 minus N1 by R. So in case when refraction takes place from denser medium to rarer medium, a rarer medium to denser medium, this N2 by V minus N1 by U, it is equal to N2 minus N1 by R. But when refraction takes place from denser to rarer, when refraction takes place from denser to rarer, both will change. The formula will become N1 by V minus N2 by U. It is equal to N1 minus N2 by R. Only thing is what? Both N1 and N2 will change their place. We will keep this thing in mind. Now in Lensmaker formula, we have one lens here. Suppose this is our convex lens and it is a double convex lens. This is O is the center of the lens. Now we can say this is a ABC surface, you can give the name, or you can give any name to this surface. For example, if we are providing ABC, this surface is ABC surface. An object is placed at this point. We can say that this is P point, and for this surface ABC surface, the normal is here. Where is the normal? Normal which passes from the C. So the normal is here. We have one normal. This is the normal C1, and the incident ray will come like this from object O. The incident ray will go here and it will bend towards the normal, and it will form the final image at somewhere. If this surface is not there, it will form the image here. Where it will form the image? At I1. Now if we have, and for this surface ABC surface, we can write what we can write. We can write the equation. Equation is very easy, N2 by V minus N1 by U. So we can write N2 by V minus N1 by U, it is equal to N2 minus N1 by R, equation 1. But here V is this OI1. So N2 by OI1 minus N1 by minus OP, because the ray is going this side. This direction is positive, this direction is negative. N2 minus N1 by R, OC1, equation number 2. But if we consider this ray, when we have considered that I1 is image formed here, we have not considered that the refraction from this surface ADC. Now if we consider the refraction from ADC surface also, so suppose this is ADC surface, and for the ADC surface, ADC, this will be the normal, and this will be the normal, this ray, actually this ray, so this ray will be this, and it has already formed the image at this point. This I dash, I1, this I1 will be the virtual object. I1 will be the virtual object for ADC surface, and this is C2, and this ray, so normally is this. Now if this ray is coming from N2, this is actually N2, so N2 to N1, so arrow will be this, so actually the ray will come like this, and it will move away from the normal. So normal is this, so it will move this side. This ray is coming like this, so it will move away from the normal. It will go this side, and the final image will form here. I will be here. So the refraction equation, this equation will become, as we have refraction from N2 to N1, so both N2 and N1 will exchange their places. N1 by V minus N2 by U, it is equal to N1 minus N2 by R. So here N1 by V, so since we have considered this is O, the O will be this, so it will become N1 by V. What will be the V? OI minus N2 by U, this is object, so OI1, N1 minus N2 by R. R will be this now, this is, so it will be opposite, so this time it will be minus OC2, this is, so it will be minus OC2. This is our equation number 3. For this surface, ABC surface, N2 by V and V, N1 by U, N2 minus N1, OC1. OC1 is the radius of curvature, and OI1 minus OP opposite to the incident ray, it is positive. This I1 act as virtual object for this surface. The final image is formed here when refraction takes place from N2 to N1. N1 and 2 will change. Now this N1 by OI minus N2 by OI 1, it is equal to N1 minus N2. This we can write this equation as OI minus N2 by OI1, it is equal to N2 minus N1 by OC2. Then we can add these two equations, equation 2 and equation 3. Add equation 2 and 3. Left hand will be left hand, right hand will be left hand, right hand. So when we add, so we'll write like this equation, N2 by OI1 minus plus, so N1 by OP, because minus plus N1 by OI minus N2 by OI1, it is equal to N2 minus N1 upon OC1 plus N2 minus N1 OC2. Then what you will find that this N2I1 and N2I1 both will cut. So it will remain N1 upon OP plus N1 upon OI. This will be N2 minus N1, N2 minus N1 will be common. So N2 minus N1, 1 upon OC1 plus 1 upon OC2. So we have to put the value of 1 upon OC1 and OC2. OC1 is this. OC1 is plus R1. It is plus R1. And OC2, this, because it is opposite to the incident ray, it will be minus R2. So OC1 OC, and OP is this. It will be again minus U. And OI, this is OI na. So OI will be plus V, because this is OI and OI will be plus V. So now one by one we'll put. First of all, we'll write this equation. What is the equation? Equation is N1 by OP plus N1 by OI. It will be equal to N2 minus N1, 1 upon OC1 plus 1 upon OC2. What is OP? Now you see, OP minus U, OC1 plus R, this side, OC2 this side, and OI plus V this side. So we will write first of all this value, OI plus V. So OI, it is equal to plus V, OP is minus U, OC1 is plus R, OC2 is minus R. Because the equation, length equation, this was the length. P, the ray will go here, normal. C1, the first image is formed here. I1, it will act as a virtual object, final image will form here, and the second normal is here. This normal is C2. C2 is the normal for this surface, C1 is the normal for this surface, I is the image. So this is O. So OC2 will be minus R, OC1 will be plus R. This direction is plus. So this is from this. Okay, now we have this N1 OP plus N1 upon OI. We'll put the values. N1 OP is minus U plus N1 by V, N2 minus N1 OC1, 1 by R1 plus 1 by minus R2, and then we can solve, take N1 common, 1 by minus U plus 1 by V. This is equal to N2 minus N1, 1 by R1 minus 1 by R2. Or we can write it 1 upon V minus 1 upon U, it is equal to N2 minus N1 by N1, 1 by R1 minus 1 by R2. Then in this equation, what is this? This equation, you can say it is fourth. This equation is fourth. This equation is 5. Now again we will write equation 5. 1 by V minus 1 by U equal to N2 minus N1 by N1, 1 by R1 minus N2. So we will write here N 1 by V minus 1 by u equal to n2 minus n1 upon this n1 will come here 1 by r1 minus 1 by r2. If u it is at infinity, the image will be formed at focus. So 1 upon focus minus 1 upon infinity, n2 minus n1 by n1, 1 upon r1 minus r2. We can say this equation is 6, this equation is 7. So from equation 6 and 7, right hand side are same, RHS are same, hence LHS must be same. So 1 upon V minus 1 upon U, it is equal to 1 upon F. And this is our length formula. 1 upon V minus 1 upon U equal to, if 1 upon V minus 1 upon U equal to 1 upon F, the length maker formula. You do it, we will see what is the doubt in this in the class. And before class you should go through with this, and you can come with the doubt in the class. Thank you.